National Electrical Code Article 430.24 states that the AIC rating of the equipment shall be calculated when installing new equipment. This means that before you install any new electrical equipment, you must determine the available fault current at the equipment's location and ensure that the equipment's AIC rating is sufficient to withstand the fault current. The AIC rating, or ampere interrupting capacity rating, is the maximum short-circuit current that a device can safely interrupt without being damaged. If the available fault current exceeds the equipment's AIC rating, the equipment could fail catastrophically during a short circuit, potentially leading to fire, explosion, or electric shock. To calculate the available fault current, you need to consider several factors, including the utility's available fault current at the service entrance, the impedance of the service conductors, the transformer impedance, and the impedance of any other components in the circuit. You can obtain the utility's available fault current from the utility company. The impedance of conductors and transformers can be found on their nameplates or in manufacturer's datasheets. Once you have this information, you can use Ohm's law and other circuit analysis techniques to calculate the available fault current at the equipment's location. Article 220.87 requires that equipment shall be protected from the effects of short-circuit currents that it can contribute to the available fault current. This means that not only must the equipment be able to withstand the available fault current, but it must also be protected from any short-circuit currents that it might contribute to the system. For example, a motor can contribute to the available fault current during a short circuit. Therefore, the motor must be protected by an overcurrent protective device such as a circuit breaker or fuse that is sized to interrupt the motor's contribution to the fault current. There are several methods for protecting equipment from short-circuit currents. Firstly, use overcurrent protective devices. These devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when a short circuit occurs. The overcurrent protective device must be properly sized to protect the equipment from the available fault current. Secondly, use current limiting devices. These devices, such as current limiting fuses, are designed to limit the amount of current that flows during a short circuit. This can help to protect equipment from damage and reduce the risk of fire or explosion. Thirdly, use surge protective devices. These devices are designed to protect equipment from voltage surges, which can be caused by lightning strikes or other electrical disturbances. Voltage surges can damage equipment and can also contribute to short circuits. Fourthly, use properly sized conductors. The conductors that supply power to the equipment must be sized to carry the available fault current. If the conductors are too small, they could overheat and cause a fire. Fifthly, use properly grounded equipment. Grounding the equipment helps to ensure that any fault current will flow safely to ground, reducing the risk of electric shock. Ensuring that electrical equipment has an adequate AIC rating and is properly protected from short-circuit currents is crucial for electrical safety. Failure to do so can result in serious injury or death. It's important to always consult with a qualified electrician to ensure that your electrical system is safe and compliant with the National Electrical Code. The available fault current must be calculated accurately. An inaccurate calculation can lead to the installation of equipment with an insufficient AIC rating, which could have serious consequences. Consider the source impedance when calculating the available fault current. Source impedance includes the impedance of the utility transformer, service conductors, and any other upstream components that contribute to the fault current. Neglecting source impedance can result in an underestimation of the available fault current. Coordinate overcurrent protective devices. Overcurrent protective devices, such as circuit breakers and fuses, should be coordinated to ensure that the device closest to the fault clears the fault first. This helps to minimize the amount of damage to the electrical system. Maintain proper documentation. Maintain accurate records of all AIC calculations and equipment AIC ratings. This documentation will be helpful for future inspections and maintenance. The National Electrical Code provides detailed requirements for calculating AIC ratings and protecting equipment from short-circuit currents. Familiarize yourself with these requirements to ensure that your electrical system is safe and compliant. The calculation should be performed by a qualified electrical engineer or other competent person who has a thorough understanding of electrical circuit analysis. Incorrect calculations can lead to dangerous situations. The available fault current at a specific point in an electrical system is the maximum current that could flow if a short circuit were to occur at that point. This value is crucial for selecting electrical equipment with adequate AIC ratings. The formula for calculating fault current typically involves dividing the system voltage by the impedance of the fault current path. The impedance includes the source impedance, conductor impedance, and any other impedance in the circuit. Software tools are available that can assist with fault current calculations. These tools can simplify the process and improve accuracy. However, it's important to understand the underlying principles of fault current calculation to properly interpret the results. Regular inspections and maintenance of electrical equipment are essential for ensuring continued safety and reliability. During inspections, check for signs of overheating, loose connections, and other potential problems that could increase the risk of a short circuit. When replacing electrical equipment, always verify that the replacement equipment has an AIC rating equal to or greater than the calculated available fault current at the installation location. Consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. Electrical codes and regulations are constantly evolving. Staying up to date with the latest requirements is essential for maintaining a safe electrical system. The NEC is updated every 3 years, so it's important to use the latest edition. Proper training is essential for anyone working on electrical systems. Make sure you have the necessary skills and knowledge to perform the work safely and correctly. Working on electrical systems can be dangerous if not done properly. Always follow safe work practices and use appropriate personal protective equipment. Always to energize electrical equipment before working on it. Use a qualified electrician to perform any electrical work that you are not comfortable doing yourself. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Make sure all electrical equipment is properly grounded in accordance with the NEC. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock. GFCIs detect ground faults and interrupt the flow of current. They are required in many locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or AICs, are designed to protect against fires caused by arc faults. AICs detect arc faults and interrupt the flow of current. They are required in many locations, such as bedrooms and living rooms. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes or other electrical disturbances. SPD divert the surge current to ground, protecting the equipment from damage. Regular testing of electrical safety devices, such as GFCIs and AICs, is essential for ensuring that they are working properly. Test these devices monthly to verify that they are functioning correctly. If an electrical safety device fails to operate properly, it should be replaced immediately. Ignoring the AIC rating calculation and equipment protection requirements can have serious consequences, including electrical fires, equipment damage, and personal injury. It's crucial to prioritize electrical safety and follow the NEC requirements to minimize these risks. Always use listed or labeled equipment. Listed equipment has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, or ALL. Labeled equipment has been marked with the manufacturer's name, trademark, or other descriptive marking. Using listed and labeled equipment helps to ensure that it meets safety standards. Proper installation is essential for electrical safety. Follow the manufacturer's instructions carefully when installing electrical equipment. If you are unsure about any aspect of the installation, consult with a qualified electrician. Electrical systems should be inspected regularly to ensure that they are safe and in good working order. Schedule regular inspections by a qualified electrician. The frequency of inspection should depend on the age and condition of the electrical system, as well as the type of occupancy. Electrical hazards can be present in any environment, but they are more common in certain industries, such as construction, manufacturing, and mining. Take extra precautions when working in these environments. Always be aware of your surroundings and look for potential electrical hazards. Never touch electrical equipment with wet hands or while standing in water. Water is a good conductor of electricity, and touching electrical equipment with wet hands can result in electric shock. Never overload electrical circuits. Overloading a circuit can cause the wires to overheat, which can lead to a fire. Use the correct size extension cord for the load. Extension cords are rated for a certain amount of current. Using an extension cord that is too small for the load can cause the cord to overheat, which can lead to a fire. Never run extension cords under rugs or carpets. This can trap heat and cause the cord to overheat, which can lead to a fire. Keep electrical equipment away from flammable materials. Flammable materials can easily ignite if they come into contact with overheated electrical equipment. Turn off electrical equipment when it is not in use. This will save energy and reduce the risk of fire. Report any electrical hazards to your supervisor or to the appropriate authorities. Ignoring electrical hazards can put yourself and others at risk. Electrical safety is everyone's responsibility. By following these safety tips, you can help to prevent electrical accidents and injuries. Understanding the available fault current and the AIC rating of equipment is vital for maintaining a safe electrical system. Ignoring these factors can lead to dangerous situations and potential hazards. So, always remember to calculate the AIC rating of the equipment, protect equipment from short-circuit currents, and consult with a qualified electrician when needed.